In this class, now I would like to explain you definition of a function. So to know the definition of a function, we people should know relations and sets chapter. You know, relation is a subset or equal to Cartesian product of two non-empty sets. So we know the definition of Cartesian product of two non-empty sets. A cross B will be defined as x comma y such that x belongs to A and x belongs to B. So this is the definition of a relation. R is a subset or equal to A cross B. You know how to find subsets of the given set. Here A cross B, A and B are two non-empty sets. So A cross B will be defined like this. So it may have some elements. If it contains n elements, then how many subsets are possible? As we know, 2 power n subsets are possible for this set if it has n elements. All those possible subsets will be called as relations. Okay, so this is the basic knowledge of definition of a relation. See, now let us go to the definition of a function. Definition of a function. See, a relation f is a mapping from A to B is said to be a function if and only if every element of set A possesses or should get a unique image from set B. This is the definition of a function. See, this is one relation. F is a one relation. It is mapping from set A to set B. Is called a function. When it is called a function, if every element of set A should have a unique image from the set B. So I will give you some overlapping diagrams. Okay, I will give you some relations. Whether those relations represents a function or not, we will see. See, observe this relation. This is set A, set B. One relation is mapping from A to B. Now here, let us take 3 elements in set A. Here you take 2 elements in the set B. Is this relation represents a function? No. Why no? Because see here, relation is mapping from A to B. In this relation, in the set A, 3 is not having any image from the set B. Hence, it is not a function, but it is a relation. Okay, but this relation is not a function because 3 will not have any image from the set B. Because according to the definition of a function, whichever elements are there in the set A, whose must be mapped by any one of the element from the set B. It should get a unique image from the set B. Okay, this 3 is not having any image from the set B, hence it doesn't represents a function. Now observe this relation A, B. Now let us name this function as h. Say 1, 2, 3. So here you can take 5, 6. Now tell me, is this represents a function? Is this represents a function? See, 1 is mapped to 6, 2 mapped to 5 as well as 6, 3 is mapped to 5. So tell me students, is this represents a function? No, it is not a represents a function, because this 2 is having 2 images from the set B, but as per the definition of a set, it should get a unique image. It should get a unique image, but here 2 is having a double images. Hence, this relation is not a function. Okay, so this is a one-to-many relation. This one-to-many relations will not represent a function. Okay, right. Now observe this. A, B. See, let us name this function as G. You can take here 1, 2, 3, 4. Here A, B, C. Is this represents a function? See, this is one relation. Is this relation represents a function? Yes, because this relation is satisfying all the conditions of the definition of a function. Hence, this relation represents a function, because every element of this set A has a unique image from the set B, and no element will have more than one image. Hence, this relation represents a function. See, observe these 3 overlapping diagrams. So, why it is not a function, you know, because 3 is not having a unique image. And come here, this relation is not a function, because 2 has more than one image. So here, every element of set A has only a unique image from the set B. Hence, this relation represents a function, because no element is empty. All are mapped by elements of set B, and no element is having more than one image. Hence, this relation represents a function. If it is a function, so here how it is mapping from set A to set B, no? So this set A will be called domain of this function, and a complete set B will be called codomain. A will be called domain, G will be called codomain. Okay? Suppose if B has, see, I will give you one more example. Now see this. One, two, three. Here you can take A, B, C, D. Is this a function? Yes. See, observe this relation. No element is empty. Whichever elements are there in the set A, which has a unique image from the set B. So no element is having more than one image. Hence, this relation represents a function. Now, what is domain? Complete the set A will be called as a domain of this function, and set B will be called as codomain. Set B will be called as codomain. See, in the codomain we get A, B, C, D elements, and right range. So which elements comes under this range? whichever elements of set B will be mapped by the set A. So which are mapped by set A? A, B, D. So whichever are mapped by the elements of set A, which comes under range of this function. See the difference between the codomain and range. Complete set B will be called as codomain, and range, so whichever elements are mapped by the elements of set A which comes into the range. Okay, right, observe this. Next, number of possible functions from set A to set B. Suppose if a function is mapping from set A to set B, then how many functions will be possible from set A to set B? See this overlapping diagram, A to B. Now here you can take two elements, here you can take two elements. So here 1 maps to 5 and 2 maps to 6. Is this a function? Absolutely. So it represents a function because it is satisfying all the conditions of definition of a function. See, here same elements you take in the set A and same elements you take in the set B. Here 1 may be mapped to 5, see 2 may be mapped to 5, and you can take the image of 1 as 6. So this is one more possible functions from set A to set B. Am I right? So still any more? 2 more are possible because see this A, B. Let it be F1, F2 and F3. 1, 2, 5, 6. So if all may be mapped to 5. So one more function also possible from the set A to set B. Here 1, 2, here 5, 6. So even these two elements can be mapped to 6 now. See, is this represents a function? Yes. See, these two have a unique image from the set B. These two have a unique image from the set B. Hence, these two represents functions. Even these two are also represents functions. Total, how many functions are possible from set A to set B? If a set A has two elements, if the set B has two distinct elements, 4 functions are possible. These are the possible functions from set A to set B. But if the set A and set B will have more elements, writing these overlapping diagrams and counting the total number of possible functions from set A to set B is somewhat difficult to know. Hence, we derive one formula. Okay, by using that formula, how many functions are possible from set A to set B, we people can able to say. Okay, now let us see that formula. See, this is set A, this is set B. So in the set A, you can take n elements. Otherwise, m elements you consider. In the set B, consider n distinct elements. Okay, see my question. How many functions are possible from set A to set B? Here set A is having m distinct elements and set B is having n distinct elements. How many number of functions are possible from set A to set B? Tell me. See, let us observe the first element of set A. A1 will have how many chances to get images from the set B? A1 can be mapped to B1, otherwise A1 can be mapped to B2 and so on. A1 will have how many chances? N chances. N chances. Okay? Right. Now let us go to the A2. A2 will have how many chances to get image from the set B? Suppose A1 is mapped to any one of the element, whichever element is mapped by A1, which also can be mapped to A2, no problem. Okay, for example like this, A1, A2. So suppose if A1 is mapped to 3, then A2 also can take 3 as image, no problem at all, because both are having unique image from the set B, no? It can be like this, but it can't be like this. You know, you have learned the definition of a function. It can be, but it can't be. So, here, A2 will have how many chances, tell me? A1 has n chances to get image from the set B. And come to the A2. A2 also will have n chances. And go to the next element, A3 will have n chances. And so on. M2 will have, this mth element will have n chances. Okay? So now the product of all these possibilities. So here n. This mth element will have this mth element also will have n chances. So this n is repeating how many times? M times. So now take the product of all these n's. How many n's are there? M n's. Whose product is n power m. Okay? So to get the total number of possible functions from set A to set B here, we use the principle of multiplication. You know, basically we have two counting principles, principle of addition and principle of multiplication. But in this case we use principle of multiplication. So n power m. Here n represents what? Number of elements in the B set. Number of elements in the B set. And m represents the number of elements in the A set. Okay? So number of elements in B power number of elements in A is the total number of possible functions from set A to set B. Okay? So suppose if I give you 4 elements in the set A, 1, 2, 3, 4, and 3 elements in the set B. Now tell me how many functions are possible from set A to set B? N of B power n of A. Number of elements in B, 3. Number of elements in A, 4. 3 power 4. 81 functions are possible. Okay? So through that overlapping diagrams, so it is difficult to say the number of possible functions. So that you people have to remember this formula. N of B power n of A. So in this case, we get 81 functions from set A to set B. Okay? Thank you.